In today's lesson, we want to look at the differentiation of logarithmic functions. But todotanga tadiscussa logarithmic functions aya tichitarisa musiyano uripo between ordinary level mathematics and advanced level pure mathematics. So kana tiri ku O level, let me use a different color because this cannot make part of your notes. So kana tiri ku O level, pataita logarithmic functions taishandisa the operator log. Remember takaita laws of logarithms and laws of indices, where we did and presented different laws of logarithms. These laws of logarithms are going to be to a certain extent applicable even to advanced level mathematics. But what happens in advanced level mathematics is we are then going to use what is called a natural logarithm. Lin, not ln. It's like this, natural logarithm. Kana mchida ku understand why we take this shift from the log to the natural logarithm. It is because of many reasons which you can research, but one of the reasons is for the sake of convenience. The natural logarithm is more convenient than using the log. And one of the reasons is we know kuti log kana chishandisa inenge chida a base. Satechiti log a base b. But kana tichishandisa the natural logarithm, we do not necessarily need a base. Saka ikuku kusatoda base makes using the natural logarithm more convenient than just using a logarithm. But remember, the laws of logarithms we did in O level are going to be applicable to a greater extent. Okay, now let us get to our notes, and I'm going to be writing them in the color white. The general rule states that, so we have a general rule, and the general rule is of vital importance. What does the general rule state? The general rule states that if y is equal to the ln of ax plus b. Saka y, which is our function, and remember even from O level kuti y taigona kumnyora takati function of x. Tinenge tichizitaura in line with the Cartesian plane, where we have x as an independent variable, y as a dependent variable. So y depends upon x. That's why y achikona kunzi a function of x. Saka y is equal to ln of bracket ax plus b is actually a function. So if we have this function, then dy dx, kureva kuti the gradient function kana kuti the derivative of that function is equal to 1 over bracket ax plus b times a. Saka this part manje, we have to box it because it's important. Iri kutiudza gradient function, iri kutiudza kuti tinodifferentiate say logarithmic functions. Saka if y is equals to ln of ax plus b, the derivative dy dx is equal to 1 over bracket ax plus b times a. So what is happening? Tichangoti 1 over what comes after the natural logarithm. Then we multiply by a. A in a special term, a is called inner derivative. Saka a anonzi inner derivative pakuti a derivative zviri mubracket riri kuuya after the natural logarithm. So I want you to listen to this quite attentively. Dy dx is equal to 1 over bracket ax plus b. So it's just 1 over zviri kuuya after the natural logarithm ln times the inner derivative, kureva kuti times the derivative of the bracket. That is so much important, and that is the general outlay of the gradient function of a logarithmic function. Saka of course we can then write it like this. Tinogona kuzoti therefore dy dx is equal to a over ax plus b. Ngoreva kuti tichati inner derivative over what comes after the natural logarithm. Kana kuti the parameters of the natural logarithm. Kana tikada kuzitaura in a technical sense. Let us have an example, and hopefully it's going to cement what we are learning. Saka our example is like this. Taudzwa kuti y iri equal to ln of 5 minus 2x. Question iri kuti titsvage dy dx. Saka dy dx in this instance inenge iri equal to 1 over what comes after ln, kureva the bracket of 5 minus 2x. That is what dy dx is going to be, multiplying the inner derivative. Saka tikatarisa bracket ra 5 minus 2x, what is the derivative of that? We know kuti the derivative of a constant, kureva 5 anenge ari 0. Then the derivative of minus 2x inenge actually equal to minus 2. Saka this is multiplying minus 2. Saka kana takuda kunyora as a therefore, tetangoti therefore dy dx inenge equal to chi minus 2 over 5 minus 2x. Zvinenge zvatopera like that. So that is it. That is how we differentiate logarithmic functions. This is the end of our lesson. If you have any questions or if you want to talk with us directly, use our numbers on WhatsApp, or it is actually 071 521 3310, like that.